Hello, guys. My name is Pratham Komarati. I'm studying here in Tesoro College of Engineering. I'm presently doing my second semester, and the course name is Mathematics for CSE stream, and the course code is BMATS 201. And my topic is multiple integrals, world of calculus with multiple integrals. Introduction to multiple integrals. Multiple integrals are used to calculate the volume under surface in three-dimensional space. Three-dimensional space includes like x-axis, y-axis, and the z-axis, and can be used to find the mass and the center of mass and probability of events. And the applications of multiple integrals are used in like physics to calculate the mass, center of mass, and the moment of inertia. And in engineering, it is used to calculate the volume, areas, and centroids of complex shapes. Complex shapes in the sense of like cube, cuboid, triangle, etc. And in economics, it is used to calculate the production, cost, and the revenue functions in optimization problems. And in probability, used to calculate the joint probability distributions and expected values. And in computer science, it is used for image processing and computer graphics and machine learning algorithms. In image processing, like in number of pixels, etc., all those kind of things. And there are like two types of multiple integrals. One is like the double integrals, and another is like the triple integrals. In double integrals are used to calculate the integral of a function of two variables, that is in two-dimensional plane. One is the x-axis and another is the y-axis, along the following area under the surface described by the function, and explore various properties and applications of multiple integrals. And we are going to see the example later. And in triple integrals, it is very powerful tool in mathematics used to calculate the volume of three-dimensional region defined by the given function, extending the concept of integration from one and two dimension to three dimension. It is like three-dimension figure, that is like x-axis, y-axis, and the z-axis. We'll see the example later. And the example of evaluating the following integral. And this is an example for double integral. And now we are going to evaluate it. Like this is the question. I is equals to integral from 0 to 1 and integral 0 to 3 x cube into y cube dx dy. Two-dimension figure like x and the y. Now we are going to differentiate with respect, integrate with respect to x. That is 0 integral with 0 to 1 with a square bracket, and integral 0 to 3 x cube into y cube dx into dy. We have to like bisection the sum into a simpler form, and now we are going to integrate it like integral 0 to 1, and x cube is integrated like x to the power 4 by 4, and in y cube there is no x terms, so it remains as the same. And this integral form will turn into like substitution part like 3 and 0 into dy. And now we are going to substitute the values of 3 and 0 in the place of x, and it turns to be 3x to 3 to the power of 4 by 4 into y cube minus 0, 0 because whatever when we substitute with respect to 0, it remains as 0. So yeah, the answer will be like 0. So we are going to exclude it, and the 3 to the power 4 will remain as 81, and 1 by 4 we have taken as common, and y cube will remain the same, and dy, and 81 by divided by 4 into y cube into dy. Now we are going to integrate with respect to y, that is y, and we are going to take 81 by 4 as common one, and now y cube will, when on integration, it turns out to be y to the power 4 by 4 into 1 by 0, and 81 by 4 remains as common. And now we are going to substitute 1 and 0 values in y in place of y. It is 1 to the power 4 by 4 minus 0 to the power 4 by 4. And 0 to the power 4 by 4 remains as 0. So the answer will be like 81 divided by 4, that is a common, into 1 to the power 4 by 4 will come be like 1 by 4, that is 81 by 16, and the total integration will be like 81 by 16. 81 by 16. And now we are going to see the example for triple integral. And this is the example for triple integral, that is integral with respect to 0 to 1 and 0 to 2 and 1 to 2 into x square into y into z into dx by dy. First we are going to integrate with respect to x. And one more, now we are going to like do by step process, that is 0 to 1 integral and 0 to 2 integral into x square will turn out to be like x cube by q on partial differentiation, and y and z does not have any x terms, so it remains the same, into, and this 2 to the end, and this 2 and this 1 part will remain as like substitution part, like 2 and 1 into dy by dx, and we are going to take 1 by 3 as common, and again with integral 0 to 1 and integral 0 to 2 into x cube into y into z into 2 into 1. Now we are going to substitute 2 and 1 values in the place of x, and on substituting, the answer will be like 1 by 3 integral, that is the common part, and integral 0 to 1 and 0 to 2 into 8yz minus 1yz, that will give by 7yz. And now we are going to integrate with respect to y, and now we are going to take 7 as common, so it will be like 7 by 3 into integral y. Now we are going to do integrate with respect to y, so we are going to integrate like y square, that y will turn out to be y square by 2, and z does not have any y terms, so it remains as the same. And now we are going to substitute 2 and 0 values in place of y. So 2 to the power 2 by 2 into z gives into z into dz. And one more is like 2 to the power of 2 gives 4, and 2 remains the same. On simplification, it gives 2. So the total answer will be like 7 by 3 integral 0 to 1 to z into dz. And the next step will be like integrate with respect to z. So now we are going to take this 2 as common. So 7 by 3 into 2 integral 0 to 1 into z into dz. Now we are going to integrate with respect to z. So it will be like 14 by 3 into z will turn out to be z square by 2 into the bracket 1 and 0. Now we are going to substitute these 1 and 0 values in place of z. So 1 square by 2 and 0 remains 0. So we are not writing it. So 14 by 3 into 1 by 2 give rise to 7 by 3. So this is an example of triple integral. Thank you.